Without further ado, let's begin the mock lecture. While we only have 40 minutes, we hope everyone here will get an idea of what studying at our school is like. I'd like to invite Professor Kohei Kawamura from the School of Political Science and Economics, who specializes in microeconomics. The title for today's lecture is Elections as Games.
Thank you so much. I'm Kohei Kawamura. I'm professor at the School of Political Science and Economics. So a very warm welcome to the school. And let me talk a little bit about the context of the mock lecture I'm giving now. So the School of Political Science and Economics offers 3 degree programs, namely BA in Political Science, BA in Economics, and BA in Global Political Economy, 3 degrees. So BA in Global Political Economy is a joint degree double major in Political Science and Economics. And the great originality and the strength of the School of Political Science and Economics and is that, the name of the school suggests, we combine both political science and economics in our educational curriculum, and also the faculty members. So we are sort of a team of top researchers in political science and in economics. And the combination of political science and economics is very much common and popular, especially in British universities, I think. And as you may notice from my funny accent, I spent a lot of time in Britain studying and teaching economics. And WASEDA University is probably the only, or one of very few universities that offer at this school, is one of very few that offer serious degree programs in both political science and economics. And the point about our program is that if you, no matter which degree you pursue at this school, you study both political science and economics. So in your first year, you study both political science and the basics, very basics of political science and economics, and also equally importantly, you study statistics and mathematics. It's common across all students majoring in any subjects here. There are 2 ways to study economics and political science, or political science and economics, and one is with mathematics and statistics, and the other is without. So the style of teaching, the kind of political science and economics that we teach is with mathematics and statistics. And some of you may be sort of a little bit put off by that, but we put a great emphasis on quantitative methods in political science and economics, or more a broader context in social science, because quantitative skills are very much now sought after skills in industry, in government, and in any sort of areas. I mean, you may have heard of the importance of data science these days, and many sort of important positions now require quantitative skills, and this is something that we want our students to be equipped with when they graduate. So that's another feature that distinguishes our program from other degree programs in political science or in economics. So today, I want to give a little bit of sort of flavor as to how we use mathematics, or to be precise, mathematical argument to a political issue, political phenomenon. So maybe I should have been able to give a little bit of statistical methods here, how statistical methods could be used to analyze political phenomena, economic phenomena as well. But me personally, I'm an economic theorist, so I'm more of a mathematics side as opposed to sort of statistics, empirical analysis side. So I'll be talking about something I'm more familiar with. Okay. So in terms of mathematical method, we use what we call game theory, which is a branch of mathematics. So game theory is mathematical framework to understand social phenomena, social interactions among people. Okay. And everyone at this school, I mean, in the EDP, English-based degree program at WASEDA, at political science and School of Political Science and Economics, has to study introductory game theory, because it's been a common language in both political science and economics. So in the past, political scientists and economists would have found it very hard to interact with each other in terms of academics or discussions, because they didn't really have common language to exchange their ideas with. But nowadays, game theory, again, a mathematical framework to analyze social phenomena, has become sort of a common language. So we are now able to use common vocabulary to exchange our ideas. It's not like algebra or calculus at this stage. It's more about the mathematical reasoning as opposed to solving equations and whatnot. All right, so I'm going to be looking at, we'll be looking at how we could use mathematical reasoning to analyze an election. So what is an election? Well, election is a selection of representative through voting, something that you're familiar with. And what is voting anyway? Well, voting, we think of voting as a mechanism for collective decision-making. So collective decision-making refers to decision-making where a lot of people, or two or more people to be precise, get together and make a decision for those people, not just one individual, but multiple people. Okay? And there are many ways to implement voting. Unanimous vote, unanimous vote refers to a situation where voting system where everyone has to approve of a proposal to implement that proposal. A majority vote, plural vote. There are many ways to vote for collective decision making. And collective decision making doesn't have to involve voting. So collective decisions could be made through dictatorship or deliberation, people just talking to each other, or consensual decision making. There's no vote, but somehow people would discuss and wait until some consensus emerges. So again, we think of voting as one of many possible mechanisms through which we can reach some decision for a specific group. So the group size could vary between, from some small committee to the whole country. What's important is that we are talking about a decision for two or more people, or potentially many people. Okay. And how can we use game theory, mathematical framework, to understand elections? Okay, so let's focus on a specific issue about which the election is fought for. Okay? So suppose that the election is about the size of the government. Well, elections are not necessarily about one topic, obviously. Elections are about many different topics. But to simplify our analysis, let's focus on this particular issue, the size of the government. So people in a country would decide the size of the government here. So the choice is between large government and small government. So large government involves a high tax rate. So government takes a lot of tax from people, and then, but instead will redistribute the wealth, the money, in such a way that people have some good, generous welfare policy from the government. And a large government would typically features a more governmental intervention, more regulations on education, market transactions, and, well, people's lives in general. And what about small government? The small government would charge a lower tax, but instead the government doesn't have much money to spend because it doesn't collect so much money from its people. So the welfare policy could be minimal or less generous than with a large government. And in general, such a government would involve less governmental intervention compared to a larger government. So there would be less regulations on people's lives in general. Okay? And the size doesn't have to be just binary, large or small. It could be somewhere in between. The point is that the one country should have one government, right? So it's a situation where a collective decision-making becomes important. So people have to get together, people have to somehow decide. They don't have to agree necessarily, but they have to decide what the government should be, what their government should be like. Another important point is that each citizen, each member of the society may have a different taste, different preference for the size of the government. Typically, the healthy young people don't need much sort of, welfare policy because they don't go to hospital too often, and they may not have kids, and they would earn enough money to sustain their lives. So they might, I'm not saying that they always prefer a small government, but they tend to prefer a small government. On the other hand, the elderly people, the elderly, would tend to prefer a large government, generous welfare, generous pension, and generous medical support. And child-raising couples, it could be somewhere in between. So people in a country or society do not necessarily agree on the ideal size of the government. They could well have different tastes, different preferences. But somehow they have to make a decision as a country, as a society, as to what the size of the government should be or what the government should be like in general. So the question is, how may the size of the government be determined through voting, through election? And I'll refer to this famous theorem in both political science and economics and in game theory called the median voter theorem. It's a mathematical theorem that sort of deals with these issues in a sort of very simplified context, what we call a model. Right? Okay, as I said, so we use a model. I mean, we're going on to the analysis of an election. And for a game theoretic analysis, we use a model. A model is a benchmark to better understand the reality, and it's a simplified framework. So in order to, in reality, elections are very much complicated, and each election would be very different. So we would first start off with a very stylized model of an election, which is very simple. So we don't think of it as this model that I'm presenting as something realistic. We would just want to use the model that I'll be presenting as a starting point for our rigorous game theoretic or mathematical analysis of an election. So it's very simple, because we, for example, focus on an election with only two candidates. Why? Not because it's realistic, but because it's simple. In reality, an election would involve many, many candidates, right? But here we focus on a two-candidate election where one of them is going to be elected. And in that election, each candidate promises a specific size of a government. And as I said earlier, ideal size of the government depends on each voter. So there are two candidates and many voters. And in fact, when I say voters, I would assume that there will be only 3 voters, again, to simplify our analysis. Okay. And each voter votes for the candidate whose policy is the closest to their ideal. And we assume, again for simplicity, that each candidate would keep their promise. We know too well, in a way, that the politicians may not keep their campaign promises, but here let's assume that each politician would stick to their campaign or election promise. And if both candidates promise exactly the same policy, the size of the government, then voters vote randomly, meaning that the voter would just flip a coin and decide which candidate to vote for. Okay, any questions so far? Well, so my model is as simple as this. Okay? So there are 2 candidates, candidate L and candidate C. L for liberal and C for conservative. And the size of the government is represented by the horizontal axis here. And as you go left, then you have a larger government, and as you go to the right, you have a smaller government, and it's somewhere in between. So a country or citizens here can pick any point on this line. So it's just that as you go to the left, the government gets bigger. As you go to the right, the government gets smaller. Okay? And naturally, you have this candidate C, conservative candidate on the right, and liberal candidate on the left. Okay, now, so those smiley faces represent an ideal government size for each individual, Mr. X, Dr. Y, and Ms. Z. And Mr. X is a very much sort of liberal guy who wants a big government, really big government, with a high tax rate. He doesn't mind paying high tax, but he wants sort of generous welfare policy from the government. Okay? And Ms. Z is very much sort of conservative sort of person who wants a smaller government. She doesn't want much government intervention. She wants a lower tax, and she doesn't need generous welfare policy. And Dr. Y is in between. Dr. Y's ideal point is in between Mr. X and Ms. Z, but Dr. Y is closer to Ms. Z than to Mr. X in terms of the ideal size of the government. Okay? And suppose now that candidate L locates his campaign promise here. And candidate C sets her campaign promise here. Now the question is, which candidate would win in this election, given that the people's preferences in terms of voters' preferences, Mr. X, Dr. Y, Ms. Z, their preferences are located this way, and the campaign promises are here for candidate L and here for candidate C. Now you see that candidate C would win this election. Why? Well, whose vote would candidate L get? Mr. X would vote for candidate L because candidate L's policy, this liberal candidate's policy, is closer to his ideal policy. Candidate L is not 100% ideal candidate because Mr. X wants even bigger government. But in terms of the choice between candidate L and candidate C, Mr. X would prefer candidate L because candidate L's policy is closer to his ideal. How about Dr. Y? So let's say she has this choice between candidate C and candidate L, and you see that candidate L's policy is closer to Dr. Y's ideal. So she votes for candidate C. And look at Ms. Z. So this Ms. Z, again, candidate C's policy is much closer to her ideal than candidate L's policy. So Ms. Z would vote for candidate C. Conclusion, candidate C would get 2 votes, candidate L would get only 1 vote, and therefore candidate C wins. Okay. Now, candidate L then knows that he's going to lose. So what if candidate L shifts his policy to the right? Because unless a politician wins an election, he or she couldn't have any influence on the policy. So now candidate L, in order to win the election, shifts his policy to the right to attract more voters, presumably. So now which candidate would win this election? Actually now candidate L would win. Why? Well, Mr. X would vote for candidate L as before. Mr. X is less happy now with candidate L than before because candidate L shifted his policy to the right. But still, candidate L is much better than candidate C from the viewpoint of Mr. X. Ms. Z will still vote for candidate C because candidate C's policy is closer to her ideal. Now, Dr. Y. Well, she would compare the policy here and policy here. And now, candidate L's policy is closer to her ideal, Dr. Y. And therefore, now she votes for candidate L. The conclusion is that candidate L now attracts 2 votes, and candidate C will get only 1 vote. Now candidate L wins. So this is not good for candidate L because he knows that he's going to lose. Now he would move his policy to the right to win an election, and he would now win. But would that be the end of the story? No. Because now candidate C would also want to win, and well, given the situation, candidate C would surely lose, and therefore candidate C would change her policy to the left or right, probably to the left, right, to attract Dr. Y's vote. Now, given that candidate C, suppose that candidate C sets the policy promise, the campaign promise, in such a way that the policy coincides with Dr. Y's ideal. Okay? The question is, how can candidate L win? Okay, so I gave just 4 choices, possibilities. So is that middle point between Mr. X and Dr. Y's ideal? So suppose that candidate L's policy is somewhere in between Mr. X and Dr. Y's ideal, right, somewhere here, or could be here. Would candidate L win? No. Because if candidate L is here, then candidate C would get 2 votes anyway, the vote from Dr. Y and the vote from Ms. Z. Okay? So candidate L cannot win this election by locating anywhere here. How about middle point between Dr. Y's and Dr. Z's ideal? Well, now candidate L is so desperate to win the election that he doesn't really mind shifting his policy to the right-hand side of candidate L. So Dr. Y and Ms. Z. Yeah, here. Would candidate L win? Actually, no. Suppose that candidate L's policy is somewhere in between here, right? That candidate L would get the vote from Ms. Z, But still, Dr. Y and Mr. X now would vote for candidate C, given the assumption that all voters vote for the candidates whose policy is closer to their ideal. Okay? So, it doesn't work. What about Dr. Y's ideal point? Here, what about the policy such that, policy that is identical to candidate C's policy, which is also identical to Dr. Y's ideal? Now, in fact, candidate L has some chance of winning, not always, right? Because both candidates now propose or promise the same policy. And therefore, from those voters' viewpoint, they're the same. So as I mentioned earlier, we assume that if both candidates promise the same policy, then voters randomize. Voters vote randomly, 50-50. So what would happen? If candidate L locates his policy here, the same policy as candidate C and also Dr. Y's ideal, then candidate L has a 50% chance of winning. Now he can win. Not always, but he can win with 50%. Okay? What if candidate L locates his policy here, the ideal point of Ms. Z? Then he would lose, because now candidate C will get Dr. Y's vote and Mr. X's vote. Okay? Conclusion. The only way, given candidate C's policy here, promise here, the only way for candidate L to win is to promise exactly the same policy as candidate C. And he wouldn't win always, but at least he has a 50% chance of winning. Any other locations, he would lose 100%. Zero chance of winning the election. And that leads to what we call the median voter theorem, which is probably the most important, one of the most important results in political science and in economics in terms of collective decision making. So first we have to think about the word median. Median is having a value in the middle of a series of values. So if you have a series of values, 1, 2, 3, 4, 5, 6, 7, then median is a middle value, so it's 4. Average is, as you know, adding up all these numbers and divide by the number of these numbers, and here it's 4. So in this series of values, the median and the average are the same. And think about 1 to 98, 99, and 100. The median is a middle value, it's 98. But the average is 60. You add up all these values and divide that value, the sum, by 5, right? So you get 60. So the median and average may well be very different. And we are arguing that the median value, the median is very important in analyzing elections. The median voter is a voter who has a median ideal policy among all voters. So thinking about this example, the median voter is going to be, is Dr. Y, because her ideal is in the middle among all these voters. And the median voter theorem says, roughly speaking, it's a simple version of the median voter theorem. I'll present a more rigorous version, mathematically slightly sort of complicated version later. And the simple version of the median voter theorem says that the majority of the voters prefer a median ideal policy. Always more than half of the voters prefer a median ideal policy to all the other policies. So the candidate who promises the median voter's ideal policy wins. And if both candidates promise the same policy, they would win 50% of the time, because for voters they're the same and they vote randomly. Okay? So what do we see from this theorem? So the basic observation is that a majority of the voters prefer the median ideal policy to any other policies. And that means that the best policy to win the election is the median ideal policy. So in fact, that turns out to be the solution of the game between the two candidates. So the two candidates' promises to win the election would depend on what the other candidate promises, right? So it's like a game between the two candidates to win the election. And we say that the solution of the game is such that both candidates promise exactly the same policy, and that same policy coincides. That policy coincides with the ideal policy of the median voter. Not the average voter, actually, median voter. So that's what if both candidates adopt the same policy at the median? Then each candidate would win with 50% chance. And actually, we don't know which one is going to win. It depends on how the voters randomize their votes. But the point is that for voters, they are what we call indifferent. They don't care which one wins because they promise exactly the same policy anyway. Okay? So what do we learn from the theorem? The theorem says that the competing candidates may still promise very similar policies. So you would think two different situations. I mean, competition might lead to what we call polarization. Candidates promising very different policies because of the competition. Well, that's possible. But here, the model says that the competition leads to what we call policy convergence. Promises get converged to the median voter's ideal. So, well, it may not sound that realistic, but for example, in Japan, no serious political candidate says, well, we should cut the welfare expenditure on the elderly. All the parties would say that, well, the elderly people should get more generous support, right? So no matter how much those political parties compete, they have that in common. So it's not outrageous to say that competition leads to actually very similar policies. And median policy, the theorem says that median policy, not average, tends to be chosen. For example, Japan is an aging society and the birth rate is declining, meaning that the median voter is getting older and older, right? So, from the politician's viewpoint, if they are to win the election, then it's good for them to adjust their policy to the older voters, I mean median voters' ideal, and the median voter is getting older and older. So then we understand why Japanese government's welfare policy is very generous, it tends to be very generous towards the elderly people. And instead, those generous welfare policy for the elderly are paid for by younger generations. And many parents are complaining about this insufficient support for their children. Okay. And also, it also captures the frustration especially in the Japanese context. The younger generation's opinions, preferences, may not be incorporated adequately in policymaking. Then there's an interesting question as well.
Is it rational for the young person not to vote? Because young people know that the median voter is somewhere up there, much older people. What's the point of going to the ballot and vote when it's raining or whatever, right? And voting is not, does require some time and effort. You have to think about candidates, you have to go to the ballot box, and you have to spend some time. Why bother? So this also captures this frustration among young people about, the government says that, young people should vote because now the people older than 18 can vote. But when the media voter is much older, what's the point? Yeah, that's another interesting observation from the model. But by the way, if young people don't vote, then a median voter would become even older, right? So as young people vote, their preferences may not be directly incorporated in this campaign promises, according to the model, but young people voting would have the effect of making the median voter younger. And ultimately, if politicians want to win the election, it's the median voter that counts, not the average voter. And now, we have a more mathematically rigorous version of the median voter theorem, which I'm not going to talk about today. I'm just saying, I want to say that it's possible to actually mathematically prove this observation. And here's a statement of the theorem, a proper statement of the theorem. Here you have this mathematical proof, which is not that complicated. There's no calculus, no algebra involved. It's just a mathematical reasoning here. So you don't have to be able to do calculation. All you need is to be able to follow logical steps here to prove that theorem more vigorously. Okay? So what's interesting, as you can see, I'm terribly excited by this kind of mathematical analysis of social phenomena, such as elections. And why it's interesting is precisely because the analysis is abstract and mathematical. Abstract model may not be that realistic because, what I presented here today is terribly simplified, simplistic, and not very realistic because in reality there are more than 3 candidates, and the size of the government is not always the sole issue, right? And a lot of voters may not vote, and politicians don't keep not always their promise, etc., etc. But the benefit of a simplified model, using a simplified model, is first it can capture many different elections because of the abstraction from a specific context, specific election. And second, if a theoretical result from the model doesn't fit the reality, well, we can modify the model. We can change the model. We can increase the number of candidates, for example. We can increase the number of voters in the model that I presented today. It is certainly possible. It would make the model, the analysis a bit more complicated and complex, but it's doable. And in fact, that process is an essential part of scientific approach. It's about science, because science has this procedure of presenting or thinking about theoretical hypothesis first and test that hypothesis. So what's important for us to follow when we want to follow the scientific procedure in this analysis is to first understand the theoretical result from the median voter theorem and then test the hypothesis using the data. And in fact, median voter theorem is not that realistically relevant, empirically relevant, empirically successful because it's just such a simple model. But there's some support for the median voter theorem. For example, in Japan, the expenditure and the result of the expenditure and also the result of the governor's election, Chiji, election of each prefecture in Japan tends to be closer to the median voters' preferences than the average voters' preferences. So there's not great support to the median voter theorem, so we have to modify the model to make it more scientifically satisfying. But there's some support for the theorem using data. Okay, so that's all I have to say for today. And if you have any questions, don't hesitate to ask me. Questions could be about the program. Fortunately, I'm in charge of the administrative side of the English-based degree program, so I can in fact answer any questions related to the whole program and also anything related to this mock lecture today. Thank you very much. Any questions? All right, good. Thank you so much. And if you just want to talk to me, just come ask me anything. So I'll stay here for about for 5 minutes or so. All right, so thank you so much.